I brought a few props. Great to be here. And so I'm going to introduce CubicPV. We are focused on enabling tandem efficiencies using perovskites, and specifically recognizing that, I spent 20 years in the silicon PV industry, and it's done wonders. But there's getting about as good as you can get. If you do everything perfectly, you can make a 27% silicon cell that'll turn into about a 25% module. I think beyond that, everybody's got perovskite on the roadmap, and the question is, how do we capitalize on that? And we understand that it's possible to make 30% tandem modules, but that opportunity to close in on not just $1 billion, but probably $100 billion opportunity for high efficiency modules is only going to become unlocked when durability is solved, which is not yet. And so if you want to have a durable commercial product, there's a combination of things you need to do right. First, you have to do the packaging right. You have to pass your IEC tests. And then you have to do your outdoor field testing. But we don't want to wait 25 years to find out whether they're going to last 25 years. And so part of the science of what we are studying is how do you do accelerated stress testing that can effectively predict how long something's going to last, and iterate on your chemistry and your processes so that you can get feedback in the lab that tells you how to make them better. And so I'm very proud to announce, and actually I was super happy that when MicroQuanta spoke this morning that they were still only at 23.9, because Martin Green only publishes that article in Progress in Photovoltaics once every 6 months. So if the next month goes well, we'll still be the world record at 24.0. And I actually brought some examples of what people are probably familiar with. If you worked in the lab making perovskites, you're making tiny little devices either on 25 or 50 millimeter samples. So we still do that. We make tiny devices at, we make tiny devices at individual pixels. And you can do spin coating to do quick iterations. But then we transfer that architecture to a serial module. And this is I call it a micro module. It's not even a mini module. It's 6 cells. It has scribes. It has the mechanisms of the interconnection. But you can do things that are not necessarily fully scalable or not necessarily fully durable. But you have to do a lot of things right in order to make a 24% mini module. And so this is a great exercise. We worked with Kaiju's team at NREL. We actually ship samples back and forth. Half the steps are done in our lab. Some of it goes back and forth multiple times. And we're particularly proud in that this is the first time on this. We generated this plot ourselves by looking at the green tables over the past, 8 years now. And this is the first time that this serial module category has been reached by somebody in the United States, at least. And actually, EPFL was the only one that was in the Western hemisphere. But so that's possible. You can make a 24% top perovskite only module. We made transparent back contact versions of this. So the sample I have here is a transparent back contact, and we can get 23%. There's just a loss in optics. But you can effectively get very close with a transparent back contact, 23% top cell, with optical transmission such that we're measuring 7% plus from our bottom cell. So we've actually effectively demonstrated the potential of 30% tandem. And so the next thing we do is we make a slot die coated version of that on 150 millimeter glass. And it's basically the same chemistry and the same stack, but area scaling and uniformity becomes more of a concern. And we're doing slot die coating, and the drying and annealing processes are captured as well. So in this case, I'm making an 18% top module, but this is a more durable chemistry. And some of the things that we do to get that champion level efficiency, we purposely avoid them because we're recognizing that they're not going to last for 20 years in the field. So this is a durable product that has a transmission, and we actually have a silicon bottom cell mounted. In this case, it's just a single silicon cell, but it's more than 7% efficiency. So that's north of 25% as a demonstrated product. And then what we've made investments in over the past year is equipment that enables us to do coatings on the next size up. So this is